So I've been looking at the NICE guidance because we're interested in some of the CKD work, and one of the things that I saw was the use of the four-variable kidney failure risk equation. The idea being that if patients have a higher than 5% 5-year risk of needing renal replacement therapy, then we should consider referral to the renal team. Now, NICE has been very good. They've given us the formula that they'd like us to use, which is this one here, but they've actually gone one better, and inside their tools and resources page have given us a link to an Excel page, the four-variable kidney failure risk equation, which looks a bit like this. So you can't see it, but the formula from this page here has been put into Excel for us to go out and put in the patient's age, sex, 0 for female, 1 for male, latest eGFR, latest ACR. And because I love these things, I thought, hey, I'd have a go at building a calculator for this inside EMIS. Unfortunately, calculators are medical devices, or fortunately, so any calculator that we build ourselves, we can't share or sell or give to people without MHRA approval, but I think it's useful sometimes to see how calculators can be done. Now, you can build custom calculators inside templates. You can also do them inside concepts. So I'm in Concepts Manager. I've deleted out some of the screen here because I don't want to share any patient identifiable information. And I think it's useful to start just with showing how a calculator inside a concept works. So when we're choosing concept, we will need to choose, you can just about see it, rule based on existing concepts. Now what we need is a concept that'll just first pass for everyone. So for my patient group, I'm just going to choose one of EMIS's concept for just registered patients. So I'm just going to say anyone who is a registered regular patient is true. And then in the next stage, here where it says click here to add a custom result value, here is where we can click and say the normal concept value. Instead of that, we're going to put the result of the calculation. Now here is a very similar calculation page to the one you may have seen if you've built one inside templates. Now this is where you have one box for the elements you want to use in a calculation and this box for the calculation. So if, for example, you want to say, hey, I want age minus weight, you would put a concept here for age, a concept here for weight, and you put here age minus weight. Now what this means is we need to create the concepts for the four variable that give us a figure. So we need a concept for eGFR that tells us the value of eGFR. We need the same one for age, we need the same one for gender, and we need the same one for ACR. So I'm going to cancel this one for now because we need to first create those concepts. So I'm going to cancel this and cancel this without saving it. And the first concept I'm going to create is just the gender concept. So this time I'm going to go to concepts, I'm going to choose a clinical code concept, and in this one the clinical code will simply be the patient's gender. So I'm going to choose gender here, I'm going to choose male. Now the idea here is that I'm going to choose, if the gender is male, the result I want to give for if the gender is male is the fixed value 1, so that when we take that concept into the calculator, I know that if it's true, it'll give the value 1. If the person is not male, usually I guess that's going to be female, the value will be 0, which is what's used in the calculators for the four variable. And the patient I'm currently testing on is a girl, so if I test run this concept now, it'll come back, it'll return the figure 0 because it's a female. And I'll save and close that concept as, in my CKD concept here, I'll say male equals 1. Now we need to do the same thing for age. We want to have a concept that gives age as a result, and the same thing for EGFR and ACR. Now these are a little more complicated, and I'll explain why. So again, what we'll do for the age concept is a rule based on existing concepts. Now I need a concept that'll pass everyone, so I'm going to go for the registered regular patient concept. Is true, and then I'm going to put the value here. Now what I want here is I want the figure here to be the patient's age, and this is where I have to use the result of the concept age. So I'm going to look for EMIS's age concept, which is here, and I'm going to say I want it to give the result of the concept age. And when I test this, it tells me that the patient's age is 13,143 days. So I'm going to save that for now. In my CKD concept, I'm going to put age in days. It's worth being aware that when we're using the calculation later on, it's age in years, so we'll just have to divide that number by 365, but I'll come back to that later on. Now I need a concept that gives the latest EGFR. So again, it's clinical codes, and this is read code because we're still in Wales. So I'm going to choose EGFR, and the ones I'm using 451E and 451G. And if I choose those, now all this concept is going to give me is just that this patient has an EGFR. And if I try and put a result here, if I put the normal concept value, it'll just return the read code. What I need is, for now, is simply to save this as a concept for EGFR in my CKD concepts here. So EGFR, and I normally put latest as it's the latest EGFR. Now I want a concept that gives me the actual figure for that. So again, we're going to have to do this little thing, rule based on existing concepts, where I'm going to choose regular patient again, when it has a think. And this time around, what I want the concept result to give me is the result of that concept EGFR. So I have to find that concept here, so I'm going to find it in my folder, CKD concepts, EGFR latest, and that is now going to tell me the figure for the latest EGFR. So if I test run this, you'll see it comes back to 32 in this patient. And I'll save and close, and I'm going to save that as EGFR figure for calculator. And we're going to do the same thing for ACR. So I will have to make a concept first, which is the read code for ACR, the albumin creatinine ratio. So we're going to go albumin creatinine ratio, urine albumin creatinine ratio, and we're simply going to save this concept as ACR latest. But what I want is, I don't want just a concept that says yes, there's an ACR. I want a concept that gives me the result, that ACR. So again, we're going to have to do rule based on existing concepts. And again, the first concept is just that this patient is a registered patient with us. So we'll do that whole registered patient business. And then what we want now is we want this concept to return the value of the concept, the result of that concept ACR, the one we just made, which is in my folder here. You can't quite see it there, but ACR latest. And when I test run that, the ACR here is 10.6, which is the latest ACR for this patient. So what I now have, I'll save this as ACR for calculator. So what we've now done is we've got the ACR for the calculator, the EGFR for the calculator, age in days, and male equals 1. So what we now want to do is we now want to make this calculation inside EMIS. Now, there are some limitations on what you can and can't do inside EMIS, so we've had to play with the formula a little bit, and I'll show you this. So this formula is this long thing here, which is 1 minus 0.9570 to the power of the exponential of the beta sum. Now the beta sum is this long calculation here, which is where you've got age divided by 10 minus 7.036 times minus 0.2201 in brackets, etc. Now what that is here, so that's 1 minus 0.9570 to the power of the exponential power of beta sum. Now exponential is Euler's number here. The exponential of a brackets beta sum is exponential to the power of beta sum, which is the same as the Euler's figure to the power of beta sum. When we do x to the power of ab, it's the same as x to the power of a, all of that to the power of b. The reason we're having to do this is EMIS doesn't allow us to do some of these calculations, but what we can simplify it all down to is that it's going to be 0.9579 to the power of 2.7182818284, similar to pi. Euler's is one of these mathematical constants, and then that lot's all going to be to the power of the beta sum, and all of that taken away from 1 times 100 to give you a percentage. But the first stage anyway is using our 4 figures to make a calculator for the beta sum. So that's what we'll do first. So again, we're going to make a concept, which is a concept which the rule built on existing concepts. And again, we're going to say just the first concept, just to get it to pass, is just that this patient's a registered regular patient. I'll say that's true. Now we're going to start doing fancy calculators. So the custom result value here is going to be the result of the calculation. Now here is where we're going to put the 4 variables in. So the expression parameters here are going to be, now you can add a code here, but we're not doing that, we're adding the concepts that we built earlier. So the first concept that we built, we're going to look for it here, is that CKD concept, the ACR for calculator. So we're just going to call that ACR. Then now what we know is that ACR will give us that figure, which for this patient was about 10. The next concept we're going to use is we want the CKD concepts here again. We want the EGFR figure for the calculator. So again, that's going to give the EGFR figure. So we've got EGFR. The next concept is this age. So again, we're going to choose that CKD concept for age in days. That's very important to remember, because when we will have to adjust the formula slightly. And then we also need their gender, which was that if they're a male, it's 1. If they're a female, it's 0. So we've got the 4 variables that the calculator uses. Now the first one we're going to make is just the beta sum. So we're going to make a concept that just gives us the beta sum from the formula. So we're not going to try and do all the formula in one. EMIS doesn't like that. So we're just going to make the beta sum, this formula here. So to do this, you'd need the formula in front of you on a different page. But the first part of the formula is we're going to go minus 0.2201, and that's going to be times, I'm going to put it in brackets again, we need age, which is this parameter above, so you can see it offers you that parameter. Now the formula itself is age over 10, but we're going to put age over 10 times 365, so 3650. Now I'm just going to put that in another little bracket on its own inside this bracket, because we're also, for the formula, going to minus 7.036 and close that bracket. So that's the first part of this formula here. So that's the minus 2201 times age over 10 minus 7.036. and then we'll do the next part of the formula. So it's actually a multiply here, and we're going to put it in brackets again, and we're going to go, oh sorry, it's not a multiply, that was a plus for this one, apologies. So plus, and then in brackets, so the next part of this formula is this bit here, which is 0.2467 times male, 1 if it's male, 0 if it's female, minus that. So we're going to put 0.2467 times, and in brackets again here, male, so this will score, male will score 1 if it's male, 0 if it's not, minus 0.5642. We'll close that bracket down, and we also need to close the other bracket down. Then the next stage of the beta formula is minus 0.5567 times EGFR over 5 minus 7.22. So we'll go back to that, and we'll go minus in brackets, and it's going to be 0.5567 times, and then in brackets, this time it's the EGFR over 5, so we're going to EGFR, so it's offering us that parameter there, and the EGFR over 5. I'm just going to put little brackets around EGFR over 5, and that EGFR over 5 is minus 7.22, and we need to put little brackets around that, so we've got 0.5567 times EGFR over 5 minus 7.22, and we'll close. That's the next section here. So we've just done the third section here, which is this one here, and then we're going to go plus the last section here, which is plus, and we need to open brackets again, so this time it's 0.4510, and that's going to be times again, and this way it's a little fancy again. So EMIS does have a set of its own little expressions you can use, and one of these is that you can use the log, which we need to use for this next part of the formula. So this asks us in the formula to use the log of ACR over 0.113. So we need to use the log. So if you type in, if we start to type in log, L-O-G, it gives us the log, and that needs to be the log of ACR over 0.113. So we're going to put in the ACR here, over 0.113. So that was 0.510 times the log of, I'm going to put little brackets again here, the log of that minus 5.137, and I need to close that brackets off because it gets very fussy about numbers of brackets all over the place. I think I may need to close brackets off again there, and that will give us the beta sum. Oh, hang on, I've missed brackets. I think I need to take a bracket off here or add one in. I may need to add one in. Now that is now going to give us the beta sum. So this here is the beta sum element of the formula. That's the minus 0.201 times age over 10 minus etc. going through to the end. So you can see that formula there, and it's nice because you can see it. So I'll just sort of compare it with the page and make sure that I'm happy that that's, so the only main difference is because the age is in days, we've had to do it over, rather than age over 10, it's age over 3650, and then it's male will give either 1 or 0, EGFR over 5, and then this last bit is the log of ACR over 1.3, yep, minus 5.137 Yes, there we go. I put a bracket at the beginning for some reason. So that now is the beta sum. So we're going to save that as the beta sum. And if I go back to that formula, what we need to do is 1 minus 0.9570 to the power of the exponential of beta sum. Exponential of beta sum is the same as exponential to the power of beta sum. Exponential in this context is the Euler's number, 2.7182. So unfortunately, EMIS doesn't automatically do a calculator that'll do exponentials. So what we use is Euler's number, and we're going to do rule built on existing concepts. So again, we're going to go for the registered patient. And it's true. Now this calculation is going to be the first step because it doesn't seem to like doing two powers inside the same calculation in EMIS, but that's okay. So this time all we want here is the concept beta sum. And that's beta sum. So the first stage of working out this formula is just going to be the exponential to the power of the beta sum. So Euler's number, 2.7182 whatever, to the power of the beta sum. So what you can do inside these is, yes, power. So we're going to do the power of A, or Euler's number, to the power of beta sum. And that's just going to give us the result here, and I'll just test that, see if it gives us a figure, which is 2.238 here. And we're going to save that as x of beta sum. I'll save and close. And then we need to go to the next stage of the formula, which is going to be 0.9570 to the power of the formula we've just done. So we'll do another concept, which is the next stage here. So again, we'll do register patient. And now the calculation is, we want the exponential of beta sum here, so we want the concept to be the exp of beta sum. And we're going to call that x beta sum. And this time round, the power is this stage here, so we're going to do the power of 0.9570 to the power of that x beta sum. Now, we could try and jump and say 1 minus this, but it doesn't seem happy whenever I do that inside this. So we're going to save this as 0.9570 power beta power x of beta sum. And then the last part of the formula is going to be 1 minus that, and to make it a percentage we just times it by 100. So this concept now is going to be the one that gives us the 4-stage variable kidney risk score. So we're again going to go with registered regular patient. It is true. And then this calculation is a much more simple one, which is we want now that last figure, that 0.9570, is the, well, we'll just say the beta beta sum expanded, and we're going to do 1 minus that thing, which is this part of the formula. So that's 1 minus 0.9570 to the power of the exponential power of beta sum. And to make it a percentage, I'm just going to brackets around that and put 100 times that. And what that's now going to give us is the percentage. So I know this patient, I've already done it, this patient's 4-stage variable is 9.37%. So she needs a referral to the renal team. And I'm going to save that as the 4-stage variable rule. So this is 4-variable kidney failure risk equation. So the 4-variable kidney failure risk equation. So when I test that on this patient, it gives me the figure 9.37. Now if I now go into the same calculator that they've given us, I'll put the patient's parameters in there. So this is a 35-year-old who's a woman, so scores 0, eGFR 32, ACR 10.6, and it tells us the 5-year risk here is 9.334. I think the concept was ever so slightly different. Let's have a look. I'll see if I can just get there. And when I test that concept here, so it was under, there we go, so 9.334, 9.37. I think it's probably to do a little bit with Euler's figure, and but that is effectively a calculator for the 4-variable risk equation inside EMIS. Now you can do the same sort of calculators for things like latest eGFR, and you give you a figure, eGFR latest, eGFR from a year ago, and you do 100 minus 100 times the thing. It gives you a percentage drop of eGFR in the past year. So if we did that for this sort of last, you'd see the percentage drop in the last year was 60%. Anything over 25, of course, being bad. And we can do the same sort of calculators for just straightforward eGFR drop, where you can get the eGFR from a year ago, eGFR latest, and just the eGFR a year ago minus the latest, and that would tell you that this person's eGFR dropped by 47 in the past year, which is over the 15. And you could put all the various things together, so you can find out the ones where their risk is more than 5%, or their drop has been more than 15, or more than 25%, or ACR over 70 not diabetic, or ACR 13 hematuria, and you could have then protocols or alerts just advising you that this patient really should have a referral to the renal team.